You know, sometimes I this is actually pretty funny to me. I'm just like sitting around and I'm like thinking to myself, I'm like, how can I prove a triangle is congruent? Like that always comes to my head like whenever I'm just thinking. But I'm so glad I took the time and I just learned. I just learned it's that easy. I looked at papers, I cried. What are congruent triangles though? That's like the first thing we have to understand in order to know how to prove that they are congruent. What are congruent triangles? The triangles with the same size and shape are classified as congruent. These fools over here, they got their sides and angles are also congruent. Like this side is congruent with that side. This side, this side, this side, this side. Angle, 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 angle. Duh. It's that simple. Okay, here's another example. Angle D and G are congruent. They share the same degree measure as 1/16, as you can see. All sides are also congruent. IG is congruent to DF. So IG 6, DF 6. Same number, congruent, easy as that. Easy as, hold on. This is not even my script. Even though two of the lines, bada bop boom, aren't even like EF and HI, hi, hello, are missing. They ain't there. They're like on a vacation. So let's just say they're both 5. Boom. Those are congruent. So making triangle DF congruent to do GHI. Now we're going into ways you can prove it. How can you prove a triangle is congruent to another? These are the common ones. Ceiling gang takes the common ones. We over here are floor gang. We are superior. Here are two common ways people usually know they're congruent. So here's same side, same thing, angles, and same size. So like we said in the first 2 slides, these are like what we said. These are the 2 common ways, like we said before. Same side, same angle, all congruent. That makes them congruent triangles. But if we want to get big brain floor gang mode, these are what we going to need. Proving using SSS, SAS, ESA, AAS, or HL. Side, side, side. So S stands for side, A stands for angle. So side, angle, side, angle, 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 side. These are what they look like if you don't know them. But here's like, I wouldn't say like tricky part, but I would say like people forget about it sometimes. It's kind of confusing when you don't understand it that much. HL, hypotenuse, leg. Hypotenuse, right angle, right? It's only for right triangles though. I didn't think I had that still in here. So yeah, that's all. Whenever there's a right angle, it's usually gonna be this. But it could be all these because these does count as an angle, so it could be like side, angle, side. You know what I mean. Yeah, but it is a big brain. Yeah, I'm definitely not gonna read the whole thing, but I am going to anyway. So this is just going in depth of what these angles, like how to define congruence, is really just like layered, how like just words coming out of my mouth. So like SSS, 3 sides of a triangle are congruent. It could be side, side, side. They always have to be in a circle almost. Like they have to be not in a circle, but like touching like a line. You know what I mean. Like it can't skip over a lot. Why is my voice bitter? It should be like this. It can't go then this like angle, side. That would make no sense. It has to be SAS over here, side, angle, side. This just explains that with big words. ASA, angle, side, angle. This is what they look like. Angle, side. Angle, side. It's easy. You see it, you read it, you see it, you draw it. You HL. Now it looks like a lot more work than what it really is. It's so simple. If the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle. Hypotenuse, they're always, whenever there's a right triangle, it's always going to be the same. The angle is always 90 degrees, so that's always the same. But the legs, not the leg and the side, the leg and the side are congruent. they have the same measure, the same length. Here are some tips that bigger brain people use. I am one of those people. This is I'm pretty sure this is like a whole nother project that I just did for somebody else, but I could care less. So vertical angles, boom, bang, bang, they make an X. They're always going to be the same angle, A and B, or the same measure. Definition of bisector, bop, bop, bop. Oh, you'll see that a lot. That's one of the common ones when they're sharing the same side, which like these like definitely go into. Both the triangles are touching and sharing a side, so like that. So like that line bisects these two. Actually, it doesn't look like it over there. This definitely does. This definitely does. This definitely does. As you can see, 90-90. Definition of midpoint. With a bisector, the legs are split evenly. So like this. They're with a bisector splitting the two triangles or the line that puts them together. That is basically like a midpoint for both sides. So this is congruent to that side. It's that simple. Reflexive POC. Reflexive POC. When two triangles share the same side, the side could be written congruent to itself. Yeah. So like up here, this side is RN is congruent to RN. It's that simple because it's the same line. They both share the same line. There's no other line. So RN is congruent to NR, RN, whatever. Alternate interior. I'm pretty sure like I get like confused on how to explain it because it's like it's very simple when I see it, but I'm pretty sure other people can't agree. All right. So two parallel sides of two triangles share a congruent inside angle along the shared side. So that just sounded so confusing. But if these two were touching and the parallel line ran through here and here, then boom, bang, these are congruent, even though they already are because it's two congruent triangles. Corresponding two angles that correspond inside two parallel. So it's basically the same as corresponding. Whenever you see parallel, there's always going to be congruent angles when two triangles are touching or next to each other. Whenever there's parallel lines, yeah. But I think that's pretty much it. Yeah. We're excited. I got Google Images. I got some notes and some homework that I got some information off of. And the CEO of Swag, he will not let you go, dough.